The function f is defined by f of x is equal to 12x over 3x plus 4, where x has to be greater than or equal to 0. Part A says to find the range of f. So I'm going to put this into a graph, put this into your graphing calculator, and you should see something that looks like this. So let's think about what the range is going to be. Remember, it's the y values. And I'm only looking at the part of the graph where x is greater than or equal to 0. So I'm ignoring all of this and this. And we can see that x, when x is 0, y is 0. And we can see that it gets bigger and bigger. And we can see it's tending towards, we've got an asymptote here at 4. So I know that f of x has to be greater than or equal to 0. It can equal 0 here because x can equal 0. And then it gets closer and closer and closer to 4, but never actually touches 4. So this is the range of my function. Part B says to find the inverse function. So I'm just going to start by writing y equals 12x over 3x plus 4. And then I'm going to swap the x and the y around because that's what the inverse function does. Now I'm going to make y the subject. So multiply both sides by the 3y plus 4. Expand the brackets. I'm going to move all of the y's to one side. I'm going to factorise the y. And then divide both sides by the 12 minus 3x. And this is my inverse function. Then we should write down the domain of this function as well. The question's not telling me to, but I think it's good practice to write down the domain for this as well. So the domain for the inverse function will be exactly the same as the range of the original function, which we worked out in part A of the question. So I'm just going to say that x has got to be greater than or equal to 0, but less than 4. Right, so that's part B done. Part C, we have to show that f of x is equal to 9x over 3x plus 1. So we want to substitute the f function into the f function. So I'm going to substitute this f function into the f function here and here. So we've got 12 lots of the 12x over 3x plus 4 divided by 3 lots of the 12x over 3x plus 4 plus 4. Right. Simplifying this then, the 12 times the 12x is 144x. And that's over the 3x plus 4. On the bottom here, we've got 3 lots of the 12x over the 3x plus 4 plus 4. I'm then going to multiply top and bottom here by 3x plus 4. because that's going to cancel this fraction here and this fraction here, and then we'll just have the 4 times the 3x plus 4, which will leave me with the 144x on the top, the 36x, plus 4 times the 3x is 12x, 4 times the 4 is 16. Collecting like terms, the 36x plus the 12x is 48x. And then if we divide top and bottom by 16, that gets us to the desired answer. So that is part C done. Finally, part D, we have to show that f of x, which is this thing, equals 7 over 2, has no solutions. So if I were to solve this, or to try to solve this, I would multiply both sides by 2 and multiply both sides by the 3x plus 1. So 2 lots of the 9x is 18x. Then 7 lots of the 3x plus 1. Subtract the 18x from both sides. And I find that the only solution to this equation would be minus 7 over 3, but the function f of x is only defined for positive numbers. So x is greater than or equal to 0, so f of x equals 7 over 2 has no solutions.